Hi friends, welcome back to my channel. In this video, we are going to discuss about moments in statistics. If you are new to this channel, please press the subscribe button and click on the bell icon to get notified. What are moments in statistics? Moments are a set of statistical parameters to measure a distribution. Moments are very helpful in describing the distribution. But why to use moments? Moments are used in variety of application to describe the statistical properties. For example, moments can be used in image processing to describe the shape of an object in an image or to identify the patterns or features in a set of data. Moments can also be used to compare different sets of points or to measure the similarity between two sets of points. Moments can also be a very useful tool for understanding the relationship between different sets of data. The most commonly used four moments are mean, variance, skewness and kurtosis of the distribution. So let's look into each one of these moments in detail. The first moment is mean. The first moment of a set of points is a measure of mean or average value of the points. It is calculated by taking the sum of all the values in a set and dividing by the total number of points. So here you can see the calculation. And the first moment is useful measure of central tendency of set of points and can be used to describe the overall shape of the distribution of the points. So mean is the first moment. And coming to the second moment, it is variance. The second central moment is variance. It measures the spread of values in a distribution or how far from the normal. Variance represents how a set of data points are spread out around their mean value. Variance is calculated by taking the sum of the squared differences between each value in the set and the mean of the set and dividing by the total number of points. The square root of the variance is called as the standard deviation and it is another commonly used measure of dispersion of a set of points. Coming to the third moment, that is skewness. The third statistical moment is skewness. It measures how asymmetric the distribution is about its mean. A distribution is symmetrical if the value to the left and right of the mean are roughly the same, while distribution is skewed if the values are not symmetrical. So the distribution can be symmetrical or not symmetrical. The skewness is calculated by taking the sum of cubed differences between each value in the set and the mean of the set and dividing by total number of points. So the calculation is as below. We can differentiate three types of distribution with respect to its skewness. These are symmetrical distribution, positively skewed or negatively skewed. Symmetrical distribution, if both the tails of a distribution are symmetrical and the skewness is equal to 0, then that distribution is symmetrical. Whereas in positively skewed, in this type of distribution, the right tail is longer. So this tells us that the outliers that have higher value or the values higher than the mean. Sometimes it is also referred to as right skewed, right tailed or skewed to the right. So these are the different terms used for positively skewed distribution. And coming to the negatively skewed distribution, these types of distribution, the left tail is longer. Wherein positively skewed, right tail is longer. Wherein negatively skewed, left tail is longer. So this tells us about the outliers that have values lower than the mean. Sometimes this is also referred to as left skewed, left tailed or skewed to the left. For a symmetrical distribution, mean, median, mode will be equal. For a positively skewed distribution, mode will be less than median and mean will be less than median, the large tail of high values. For a negatively skewed distribution, the mean will be smaller than median than the mode. But the above generalization is not true for all possible distributions. The fourth moment is called as the kurtosis. It measures the amount in tails and outliers. It focuses on the tails of a distribution and explains whether the distribution is flat or rather with a high peak. The measure informs us whether the distribution is richer in extreme values than the normal distribution. So this can be calculated by taking sum of fourth powers of differences between each value in a set and the mean of the set and dividing by the total number of points. We can differentiate three types of distribution based on the kurtosis. These are mesokurtic, leptokurtic and platykurtic. In mesokurtic, these types of distributions are having the kurtosis of 3 or excess kurtosis of 0. This category includes the normal distribution and some specific binomial distribution. In leptokurtic, these types of distributions are having high kurtosis greater than 3 or excess kurtosis greater than 0. This is the distribution with the fatter tails and narrower peak. Whereas in platykurtic, these types of distributions are having high kurtosis. So these types of distributions are having the kurtosis smaller than 3 or the excess kurtosis less than 0. And this distribution is with a very thin tails and compared to the normal distribution. So hope you are clear with this topic, and if you like the video, please press the like button and share it with your friends. Thank you.